Okay, in today's video, I'm going to go over what is resistance. Now, I'm not going to go into a lot of detail. I just want to give you a general conceptual background of what resistance is, kind of how we talk about it, the symbols we use, the units, the numbers, and the abbreviations, because when we deal with circuits with capacitors and resistors in them, there are several different terms that you need to be familiar with. Resistance is one of those terms, but the other ones are current, voltage, capacitance, and charge. And we use these terms when we do calculations using Ohm's law, V equals I times R. The voltage is the current times the resistance, and also when we use what I like to call the capacitor equation, Q equals C times V, the charge equals the capacitance times the voltage. And a lot of times I see people doing calculations and they're getting the right answers, but I'm not quite sure. Do they really know what the answer means? Like, what is resistance, or what is voltage, or what is current? So in today's video, as we're going to start right now, we're going to talk about what is resistance. Now, resistance, it's a little bit hard to come up with a good definition of resistance. I mean, a volt, we can just say, is a joule per coulomb. Current, we can say, is coulombs per second. But really, resistance, and it's hard to come up with a definition, especially a definition that doesn't use the word resistance. So I found this one: resistance is the hindrance to the flow of charge. Basically, it's, if you use just the equation like Ohm's law, it's really the ratio of the voltage applied to the electric, the ratio of the voltage to the electric current that is flowing through that resistor. Okay? And this is how, if we were to take Ohm's law and rearrange Ohm's law to solve for resistance, V equals I times R, you get that the resistance is the ratio of the voltage applied to the current. Now, I think it's a little bit more conceptual to think about it in terms of the current. Like, how does the resistance affect the current? So this is, the current is equal to the voltage divided by the resistance. And you can see, if we were to keep the voltage the same, keep the voltage constant, and increase the resistance, the current goes down. If you were to keep the voltage the same, keep a constant voltage, and decrease the resistance, divide by a smaller number, then the current would go up. The point being is that the current and the resistance, or the resistance and the current, are inversely proportional to each other. As the resistance goes up, the current goes down. As the resistance goes down, the current goes up. They are inversely proportional to each other. And I think that's really the main thing. As you increase the resistance, the current goes down, because that's what resistors do. They resist the flow of electrons. They resist the flow of charge. Okay? That's what a resistor does. Now, when we talk about resistance, or when we do our calculations, especially using Ohm's law, we have V equals I times R, R being the symbol for resistance. Now, that might seem pretty straightforward, but the symbol for current is I. But in this case, the symbol for resistance is R, so that's pretty straightforward. Now, the unit is a little weird, maybe, if you want to think of it like that. The unit is the ohm, okay? The unit is the ohm, and we don't just abbreviate that with an O, we abbreviate that with the Greek letter omega. Okay, so the symbol for resistance is R, V equals I times R. The unit is the ohm, and the abbreviation for the ohm is this funny looking thing, the Greek letter omega. All right, now, how do we talk about resistance, or how do we say resistance, really? We say the resistance, for example, is equal to 500 ohms. You could write it out like that. Resistance equals 500 ohms. Now, oftentimes in problems and things, you'll see it's abbreviated. Abbreviated R, capital R, equals 500 omega. We don't say omega, we just say the resistance is equal to 500 ohms. Okay, so that is just a kind of quick conceptual description of resistance, what resistance is, kind of what it does. It resists the flow of electrons and the units, and I think that gives you kind of a good place to start, having a nice conceptual understanding about what resistance is and how it affects the current. All right, so thank you very much for watching. I hope you found that helpful. If you did, you could give me a thumbs up below, or leave me a comment in the comment section. Okay, thank you very much for watching, and we'll see you in the next video.